The focus of this lesson is finding a place to live. Example 1. Rufus and Maria have both been offered new jobs in a different city. A real estate broker sent them a listing of apartments in their desired location, showing the square footage in each apartment. Use linear regression analysis to determine if there is a correlation between the square footage of a rental property and the amount charged for the monthly rent. What is the linear regression equation? And then interpret the correlation coefficient. If you look at the data in the table, you will notice there does seem to be a relationship between the square feet or size of an apartment and the amount you pay in rent, right? The lower square footage apartments seem to cost less, and the apartments with much more square footage seem to cost more. And then we see that growth as we follow along the table. All right, so in order to do linear regression, we must use a spreadsheet program like Google Spreadsheets or Numbers or Excel. In this case, we're going to use Microsoft Excel. So we have all of our data inputted into a table. The first thing we're going to do, if you remember from before, is we're going to highlight both columns, our square foot and our monthly rent. We're then going to go to Insert, Chart, and we're going to click Scatter Plots. And we're going to select our first option here. Just going to drag and move this over. And then we're going to right-click any point on our scatter plot. And we're going to click Add Trendline. A menu of options will appear on the right. We want this to be linear, and we're going to ask it to display our equation and our R-squared value. We're going to move the equation off of the line so we can see it. And while the equation is highlighted, we're going to click on the Trendline options where it says Label Options, or we see a little bar chart here. When we click on that, we're going to change it from General to Number because we're talking about numbers here. And we're going to make sure our place value is at least 2 decimal places. All right, now just to make this make a little bit more sense, we're going to modify the formatting of our table of our chart here. So we're going to go to Chart Design, and we're going to ask that it show both of our axes labeled. So we're going to have it label our horizontal and vertical axes. We know that our horizontal axis is equivalent to our x-axis, or the square footage of an apartment. We're going to put square feet. And then our vertical axis, or y-axis, is equivalent to our second column of our table, and that is the monthly rent in dollars. Now this is useful to have because then when an outsider reads this graph, we can see what is being compared. We can see that as the square footage increases, the monthly rent is also increasing. Now, a couple of things. So first thing we want to look at is how closely this information, these two things, are correlated. Now, we're going to look at this second number here, okay? And I'm going to highlight that in purple. Now, it won't let me, but that's okay. So the second number here that I have highlighted here is considered our correlation coefficient squared. Now, as we talked about in the beginning of the year, if a correlation coefficient is close to 1, that means there is a strong relationship between the two variables, meaning the line that you see here closely fits the data. Now, if the line were to perfectly fit, the correlation coefficient would be a 1. Okay, now the further you move away from 1, the worse the fit of the relationship of the line. So for example, if you had a 0.5 or a 0.4 or 0.3, those would be considered pretty weak fits. Okay, so if I was to say change one of these, let's say change this 1245 to 1700, you'll notice that the correlation coefficient drops down, and that means it has a worse ability to predict, right? It's not as good a fit. But right now what we have is our R-squared value of 0.92. Our correlation coefficient is actually the R, not the R-squared, so it's the square root of 0.92, which we'll determine in a moment. Okay, now we also have our equation here, and this gives us the relationship between the square feet and the monthly rent. Now our X represents the square feet. So let's put that here just so we can remember. And then our monthly rent, of course, is our Y. Now, this says that every 91 cents increase in monthly rent is equivalent to 1 square footage increase. So if I'm willing to pay 91 cents more, I will get 1 more square foot. Okay? And then this $403 is telling us that we will pay $403 in rent, even for 0 square feet, according to this model, which of course doesn't really make sense, but models don't always perfectly translate in real life. All right, so let's just write out our answer. So I'm going to insert a text box for us. So we know the first question was, what is the linear regression equation? And for us, that is that y equals 0.91x plus 403 and 9 cents. Now remember, in any equation in slope-intercept form, we know that y equals mx plus b is the form that we're writing this in, where m is the slope and b is our y-intercept. Okay, so we know if we wanted to interpret this, that m is 0.91 and b is 403 and 9. Now, we know that slope is written in the form rise over run, also known as the change in y over the change in x. So in this case, 0.91 over 1 is our rise over run, and therefore we would say that when our y, our monthly rent, when the monthly rent increases by 91 cents, the square footage of the apartment goes up. Apartment goes up by 1 square foot. Basically, for every increase of 91 cents, we can get an apartment that is just one square foot larger. Now, our y-intercept, like I said before, that b is the price we pay for a 0 square foot apartment. So if we were to follow this line all the way across, that would suggest the apartment was 0 square feet and we pay 403, which obviously doesn't make sense, but we're going to run with it because that's what the interpretation would say. Like I said before, when you create these models, they don't always extend perfectly into the past or into the future. But the idea is that they give you a reasonable model within a certain domain. So when or if the apartment was 0 square feet, it would cost $403.09. Okay, so that's our interpretation of our linear regression. Now, then it says it wants us to determine the correlation coefficient. So what is our correlation coefficient? Now, like I said before, the correlation coefficient is our R value. Okay, now right now we have R squared, and our R squared is 0.92. So in order to solve this, we're going to square root both sides. So we'll square root the R, and that'll give us, or we'll square root the R squared, that'll give us R, and then we'll square root the 0.92. So let's just grab a quick calculator, and we have 0.92, so 0.92, and then we're going to square root it, and we see that our correlation coefficient is about a 0.96 if we round, so 0.59, 0.96, and so we know that there's a pretty strong correlation between square foot of an apartment and the monthly rent. So there is a strong positive. That means as one goes up, the other goes up. correlation between an apartment's size, square feet, and the cost, the monthly rent. And like I said, we can see that in that the closer that R value is to 1, the stronger the relationship is. All right, example 2. Based on example 1, what is a good estimate for the amount of monthly rent charged for an 880 square foot apartment? All right, so what we're going to do is we're going to take the equation that they gave us, or that we created using linear regression. So we had 91 cents per square foot plus the 403 and 9 cents to start. Now, if I have an apartment that is 880 square foot, how am I going to determine how much this should cost? Now remember, square foot is X and monthly rent is Y. So we're looking at square feet, so that's going to be an X. So we're going to take that value, that 880, and we're going to plug it into our equation for X. So I have Y is equal to 0.91 times an 880 square foot apartment plus my 403 and 9 cents. We're going to grab a calculator, and we have 0.91 times 880 plus 403 and 9 cents, and we can see that that is $1,203.89. So $1,203.89. Now we definitely want to make sure that what we're getting here does make sense based on what we see in the table. So we're going to approximate where that 880 would have appeared on the table if it were. Now we see here 872 and 903, so we know that the 880 would occur somewhere here. Now they're saying that 872 is about $1,205 and that 903 is about $1,245, and our value is a little bit short of that amount, but remember, our model is not going to be perfect. It is within a few dollars, so it's totally reasonable. And then we're going to make the statement that an apartment that is 880 square foot, we would expect to cost about $1,203.89. All right, example 3. Use the regression equation you found in example 1. How many square feet might an apartment with a monthly rent of $1,400 have? Now note, this is almost the same idea as the other one, but it's quite the opposite as far as solving. In this case, they're giving us the cost of the apartment. In other words, they're giving us our Y value, right? They're telling us our apartment costs $1,400. How much apartment can we get? If you remember from before, we have Y is equal to 0.91x plus our 403 and 9 cents. Now, the difference here is we're actually going to be taking our Y value and plugging it in. So we have 1,400 is equal to 0.91x plus 403 and 9 cents. Our objective is to solve this equation for x, so we're going to remove anything that's on the same side of the equation with the x, starting with the plus 40309. So we're going to subtract 40309 from both sides. On the right side, it cancels. On the left, let's take a look. We have 1,400 minus 40309. That gives us 996.91 is equal to 0.91x. The 0.91 is being multiplied, so we'll divide that on both sides. Let's calculate. So we have 996.91 divided by 0.91, which is about $1,095.50. So $1,095.50. So we could expect that if we want a $1,400 apartment, that, I think I misspoke here, this is not dollars, this is square feet, that if we have $1,400 to spend, we can get an apartment that has about 1,095 or 96 if we round square feet. And that's it.